Right. Hello everyone. A warm welcome to Mastering Python course from Edureka. Hope you all are doing good. I am Sarang and I'll be your instructor for the duration of this course. Okay. Before we get started on this course, I would like to know something about yourself. So brief introduction from your end will be very helpful in driving this course in a way that it meets your expectations. So to get started, I can see Rahul. Yeah, Rahul, Anand, Tom, Jeff, Elvis. Yeah, if you could please just share one line of introduction about yourself to get us started with. And if you want to speak, let me know and I'll put you on, I'll unmute you so that you can speak one at a time. Okay, Rahul, thanks for sharing. So Rahul is working as a Python web developer for the last 6 years, and he's interested in learning more about data science and how to address big data problems using Python. Thanks, Rahul, for sharing that. All right, moving on to Anand. Yes, Anand. So Anand has primary background working on databases, and this is his first programming experience learning Python. So apart from getting expertise in Python, he also wants to learn how it can be connected to big data appliances or how it can help solve machine learning problems. Good to know, Anand. Thank you. Yes, Jeff. Okay, thanks. So Jeff is working as data scientist in Chicago for the last 8 years, and he has good experience solving data science problem using R. But of late, he realized that uh, Python also has some capabilities connecting to big data environments, doing data analysis, and is more programmer friendly. And okay, you are interested more in learning about scikit-learn, which has all the machine learning capabilities. Good to know. Good. Yes, Tom. Okay, I see. So Tom is a postgraduate student in one of the US universities, and he wants to excel at Python. Thanks, Tom, for sharing this. Yes, Elvis, you are next. Okay. So Elvis is again into using Python on his day-to-day job, right from connecting to cloud, doing some data analysis, and now he also wants to learn how it can help him address Kaggle problems. Yeah, good to know. So you are interested on Kaggle, right? All right. So get started. As I mentioned, my name is Sarang. And I have overall 9 years of experience. With respect to Python, my relevant experience is 5 years, and I have used Python extensively on web development, data science problems, doing data analysis on my day-to-day job, and I'm currently associated with Edureka, sharing my knowledge and helping students worldwide gain from my experience. So that's all about it. And just to let you know, even I at times spend time using uh, Python for solving Kaggle problems. So even I get attracted to those. So I'm sure we will have something common to share on this, especially with you, Elvis, Jeff, Tom. I know you all have some data science background, and even Rahul Anand. Yep. All right. To get us started, let me walk you over the course structure. So let me help you how it works. So as I mentioned, I have experience working on Python, and that is why I'm here helping you learn about all its capabilities. All the classes will be live online and you'll have the recording shared with you. You can raise in-class questions whenever you feel like. So when you think in I'm conducting a topic and you have some questions, feel free to shoot them, but I may not answer them immediately because I would prefer maintaining the logical flow of the topics and of this session. And once I'm done completing that subtopic, I'll definitely answer all your questions. If I miss something, please don't hesitate to raise it again, and I'll try my best to answer all your doubts. At the end of every module, I request you all to please provide feedback. This helps us improve the quality of courses at Edureka, and you have 24/7 support uh, in terms of reaching out to the technical support at Edureka, which will help you address any of the technical problems or executing any of the scripts which will be shared as part of the course inventory with you. As I mentioned, all the class recordings will be live online and you'll have access to those recordings. So let me walk you over the LMS, which is the Learning Management System tool at Edureka, which helps you access all those recordings. And by the time it gets connected, let me get back here. So for every module, we have a module-wise assessment, wherein you'll have exercises shared at the end of every module, and you are expected to submit solutions to those assignments. And based on your performance on those assignments, the regularity of submissions, and the project work completion, you will get a verifiable certificate from Edureka. Though you will get this certificate, but then your grades will vary depending on your performance on these assignments as well as the project work. But needless to say, you have guidance on all these assignments specified at under every module. And apart from that, you also have technical support helping you complete all these assignments and the project work. But it is encouraged you first try it at your own end, and then if you face any challenges, feel free to get back to the technical support. Okay, so why not get started with the course, and then I'll also spend some time to help you understand what LMS is, how the content is organized. I'm sure most of you would have got the login credentials for LMS, and if you sign in, right on top navigation bar, you have something called My Courses. So if you hit My Courses, you will get the list of all the courses which you have availed from Edureka. So if you refer My Courses and hit Python Mastering Python course, you will see the installation instructions, how to get started on mastering Python. If you want to set up a VM and do not want to spoil your existing environment, or do not prefer working on Windows or Linux, so you can probably download this VM and get started. But then this VM is an Ubuntu environment, so whatever installations you do, those will be confined to the VM. Apart from that, you have all the module content organized here, and under every module you have the class recordings, the presentation, the subtopics, the assignments, some guidance on assignments, and then how to get started on the next module. So this is all about LMS. And when you say get started, you could also access this page, which tells you how you can reach out to the technical support here. So you could rate a support ticket. If you hit support like this, you could either call US toll-free number or this India support number, select the course in which you're participating and the category. So if it's a general discussion, installation related issue, LMS issue, or any other technical or non-technical issues, leave a description and you shall get a response back very soon. So here are some of the guidelines, the software and the hardware requirements for Python. I'm sure most of you would have at least 2 gigs of RAM on your system, and you would have Python installed. I'll tell you what version of Python we will be using, so just hold on till that point before you get started on the installation. And as I mentioned, you have all the, and this is the pre-recorded sessions for all the modules and mastering Python course. So in case there is some issue with the recording in the current course content, you can still refer the pre-recorded classes, or if you want to move ahead of the class, you can refer those recordings so that next time when you join a session, you already know what is it that you will be learning, and you can be prepared in advance in terms of the questions you would like to ask. So getting back to the structure of the course, so you all know how it works, and now comes the course topics. So we will have module 1 through 10. Each module will be of duration 3 hours. At the middle of the module, I'll be taking 15 minutes of break. Uh, and then, as I mentioned, I'll be taking questions in between and answering them at the end of the logical end of every topic. Now, module 1 is more about helping you understand how to get started with Python and setting up the environment, how to run scripts, what are the syntaxes, what are the best practices to be followed when you get started on Python. Module 2 takes you a little deeper. It talks about the different sequence structures and the file operations available in Python. So this is very essential because you will deal with these structures from time to time, and you should actually have a good handle over these. Module 3 takes you more deep into functions, sorting, errors, and exception handling. So functions are the independent code units that you write in Python as scripts, and sorting is something that you should know how to sort your data on different sequence structures in Python. Errors and exception handling get you more expert in anticipating what kind of issues could be encountered in your code, so that you are prepared well in advance, uh, surrounding your code with the proper exception blocks and ensuring that you have the elegant response returned to the user. Module 4 talks about regular expressions, the packages in Python, and the object-oriented programming in Python. So using regular expressions, you learn how to generate random passwords, how to search for a particular pattern in a string, how to do substitution using a specified pattern. And object-oriented programming makes you expert in understanding uh, how to create classes and objects in Python, and how the three important principles of Wolf's paradigm, mainly polymorphism, inheritance, and encapsulation, are followed in Python. Module 5 is about learning how to debug your code. This is quite essential because many times if you encounter any issues in the scripts you write on Python, you should know how to debug those scripts, troubleshoot them so that you could get ahead and do not get stuck. It also covers connection to databases and how to set up your project skeletons. So you learn how to connect Python to relational databases, and you will know how to set up a project. And we help you learn this project setup so as to understand how to write unit tests, how to execute unit tests in the entire Python ecosystem, all through a single command. And these project skeletons are so much aligned to the shareable libraries in Python that you could also create something very useful, which you think is very useful and has not been taken up by anyone else and is not available as a Python library, and you can be a contributor to it and share your project on uh, GitHub or Python package index, which is the common source of sharing all the open source libraries. So you will learn how to set up such projects in place. So module 1 through 5 takes you deep. It's all about the depth in Python. Module 6 through 10, we talk about the breadth of Python in terms of addressing data science, machine learning problems using Python. So you will cover different libraries that help you address such problems. We also help you understand how to write your own algorithm and how to cleanse data using these libraries so as to derive meaningful insights using the predictive capabilities of machine learning. Module 8 talks about some data analysis using one of the popular libraries in Python called Pandas, and then it takes you gradually to uh, some introduction on Hadoop, where you understand the concepts and the fundamentals in Hadoop. Module 9 uh, takes you deep into Hadoop and making you understand what is HDFS, Pig, and Hive, and then finally help you understand how to connect Python to these ecosystems and get big data analysis done using Python. Last module is about web scraping. So when you already have Hadoop ecosystem set up in module 9, you would prefer uh, having the capability to pull data from multiple sources worldwide programmatically and push them to your Hadoop ecosystem. So web scraping helps you do that. You could scrape content through different websites using Python. And then last topic of this course is about project work, wherein you'll be given an assignment to do sentiment analysis using Python. So sentiment analysis is just an example. There could be different assignments as well. So similar will be the nature of other assignments. They are little complex in nature and helps you leverage all the capabilities of module put together. So this will be kind of a real capstone project at the end of this course. So moving ahead, what you learn at the end of today's module, you'll have an understanding that Python is an object-oriented programming language, and it also has capabilities to support code written in functional paradigm as well as procedural paradigm, which are the other paradigms similar to object-oriented paradigm. You will also learn how to list the users. What are the users of Python for data analytics? So some popular names that reinforce the need for learning Python, and you can also get to that level, so resolving data science problem and joining one of these big shots. Then you learn how to define identifiers, and what is the significance of indentation in Python. Moving on, we learn what are the supported list operations on numbers and operations on strings. And finally, we learn how to run a Python script. So we start gradually talking something on the theoretical lines, and then we move on to cover some syntactical sugar in Python. So what is Python? Uh, I can very well read this, but then uh, beyond this, Python is not only an object-oriented programming language, but it is a language which also supports functional paradigm, which is one of the popular paradigms in programming languages, and it has recursion capabilities. So some programming languages claim that recursion is bad, but Python actually supports it, and supports it in a way that you will also get addicted to using it quite often. Python is quite easy to program and read, and that's also one of the major factors that contributes to its popularity, because if a programming language is easy to learn and read, easy to program, and it has capabilities right from opening a simple file on a system to web scraping content and uh, addressing some of the complex data science problems worldwide, then definitely that deserves attention, and it's kind of a must-have programming language in uh, under every programmer's stack. The Python programming is quite similar to Perl. Perl is another popular scripting language, but Python has much more powerful typing and object-oriented features. So if you see below, here are some of the common uses of Python. It can be used for producing HTML content on websites. It can be used for setting up a complex structure of classes, something similar to factory classes in Java. And many organizations have also increasingly started using Python for creating web servers. So it's right there, right from creating or opening a file on a local system and generating HTML content to running a server on its own. Thirdly, it has quite clean syntax and powerful extensions. So when you write Python code, what you would write in Java for several lines spanning across pages, the same could be achieved in Python in just a mere fraction of those lines. So this means lesser code, lesser pain to maintain that code, and lesser pain in debugging that code. It supports several extensions. So when you save a Python script, the script bears the extension .py, but then when the script is executed, it is executed over Python interpreter, and Python interpreter has inbuilt intelligence to first convert that script into the compiled code, and that's where many times you will see the directory where you created a .py file, you will see .pyc file automatically created. Now, in addition to pyc, you could also have .pyo, which is an optimized compilation, but that is not so commonly used unless you have some advanced scientific computation built in your library and you would want that code to be highly optimized for a specific chipset to run. So you could also achieve that using Python, and it's just a matter of giving that as a command line argument to the interpreter when you run the Python script, and the interpreter takes care of generating files with this extension. Uh, the third extension, which is .pyd, that helps you bundle Python files into DLL libraries. DLL stands for dynamically linked libraries, which are commonly known shipment code units on Windows operating system. It means when you build something as DLL, it is expected to run across all Windows environments unless there are some major changes in between the one or the other environment. It works seamlessly, and in order to build such files, you could build Python files with .pyd extension, and this extension helps you bundle those files or ship them under DLL. And Python can also be used for text processing. Uh, so these are just few of these capabilities. I mean, they can be a long list, but these are just few popular examples to mention. And when we say it can be used for text processing, it can be used for data cleansing, data quality, data analysis, sentiment analysis. We have a very cool library supported in Python called NLTK, which is Natural Language Toolkit. And using that, we could do sentiment analysis over a piece of text. Now let's see some of these examples. Okay, so as I mentioned, Python can be used for several things. So this is one such example. Don't worry about the syntax and the code right now, because you'll learn all this in one or the other modules as part of this course. So this talks about creating some importing a library from Python which helps you support or write email text in MIME format. Then you just specify to whom the email should be sent and who's the sender, build the message, create the text, what should be the template of the message, and then split it. You define whether the text should go as a plain text or an HTML text, attach it to the message object, and then all you have to do is you create an SMTP connection using SMTP library, which requires an SMTP server port to be enabled on your system, and using that you will be able to send email to any person worldwide. So this is quite simple. Just, I would say, what, 45 lines of code, that too almost 12 lines of comments. So around 30-35 lines of code can help you send an email right from your system. All you have to do is specify what is it that you want to send and to whom do you want to send. That's how simple Python is. And if you take this example, in case we create a Python class, so you learn this as part of the object oriented principles. So Python classes inherit from object class, but as I mentioned, don't worry about the details. This is just to show you some of the capabilities of Python. So we create a header field which has the HTML header defined, then we create a body field, but then body content often keeps changing, so we specify in body what are the list of projects we have worked on, and we specify project 1. We leave project 1 detail as a template, then we specify project 2, again a template, project 3, again a template, and at last we say how the projects were implemented, and there are here is a link to some of the Python libraries, and then we give the uh, define the footer of the mail. Once we have these statics defined, we uh, we determine how to use this. So we instantiate or we define the constructor of the class, wherein we populate the placeholders which should replace the placeholders in the body. So p1 detail, p2 detail, p3 detail should actually be replaced with the content, along with the py libraries, which is also a placeholder here in this template. We fill content, and then we build the content saying add or merge header with the body, and then write this to a file. So if you notice, you do not see any web page or HTML file on my system yet, but if I run this, so it says it ran this HTML web page, and if we go to the desktop, we see a web page which says my projects.html. This is project 1, project 2, project 3, and it says our projects were implemented using Python. Please click here to refer all Python libraries. So this is the place where you find all the standard Python libraries. You could download them and start using them depending on what you need to use. Then we have the confidential footer, and it says this mail is generated from PyCharm. PyCharm is the default editor which will be used as part of this course. So HTML web page is one of the capabilities. Now there are several other things that you could do. So like I mentioned, I'm fond of solving Kaggle problems, and I'm sure some of you also do. So if you notice, there was some months ago there was this famous problem which catched everyone's attention, which was National Data Science Bowl. It had to do with the images of taken under deep sea water, and based on those images you have to identify what if a new image is taken, to what category of plankton it belongs. And to address this problem, you could write a Python script. So I used one of the machine learning algorithms called linear vector quantization for solving this problem. And I used some of these libraries like pymorph, skimage, mahotas for computing Harlick features, and then created a class called classify plankton. And if you go down, this is what was done under it. We transformed the training set, we transformed the test set, standardized the images, computed the morphology using dilation, computed Harlick features, arrived at some of the region properties, and then all this was uh, fed to a machine learning algorithm for it to learn from training features, and then when it got the test data it was able to identify if an image belonged to a particular category. However, this was not the most optimal suggestion to the problem, but then this helped me get to the list of top hundreds. So I'm sure learning Python you will also get to this level, and it's more a matter of identifying what algorithm you should be using. And if you have good handle over some of the basic syntax in Python. Like if you see, I'm trying to open up a file path, and from the file path, I'm trying to find the name of the directory. So if you know what is it that you want and you are good at Python syntax, probably this is more a matter of playing with what algorithm would fit the data, and probably you could feature in one of the top performers at Kaggle. Similar to this problem, I also had taken a stab at, uh, oh, the same problem again. I had also tried my hand at Titanic problem, which is one of the famous problems on Kaggle. So is if you notice, the script was as short as what 42 lines, and the problem was around finding out the people who survived on the ship Titanic, and if you give the new set of people about whom you don't know whether they survived or not, because such people were not found, so it is not known whether they survived or not. So if you have these two data sets, probably if you use an algorithm like random forest classifier and run it on a training data which tells who survived and what was their age and what was the economy they were traveling. So probably you will be able to figure out if the people who were not found, whether some of them actually survived or not, leveraging some of the features from the training data set. And this problem is solved in just 42 lines, and all you have to do is uh, just use few of the libraries in Python. It says Titanic problem, random forest. This code cleans up data for input into a simple random forest algorithm, and it then implements the random forest algorithm on the cleaned up data. So I'm sure you will be very fascinated with all this and would also like to try your hand at this. And just to let you know, all this is coming your way in the subsequent modules, and at the end of these modules, you will also be at a level wherein you will be able to write such as scripts and try Kaggle competitions, pull data from cloud, write to Hadoop, and do similar other jobs which others think are quite difficult to do, but then you might be an expert doing all that. So to move forward, you already know what Python is capable of. But then beyond that, there are some other reasons why you should be learning Python, and here are some of those. So Python focuses on readability, coherence, and software quality in general, and that sets it apart from other languages in the scripting world. So there are several other popular scripting languages, but then because of the emphasis of Python on these features, that is especially readability and coherence, it actually sets it apart from other languages. And that's one of the popular reasons for learning Python. Second is about developer productivity. So Python code is typically one third to one fifth the size of equivalent C++ or Java code. And as I mentioned, the machine learning problems which we discussed, if you are really good at C++ or Java, and if you try addressing those problems in this language, I can bet that your code will be way beyond 42 or 40 lines of code uh, than what we really saw addressing one of those problems. So this means if you have very less to type, you are there solving a problem faster than others. It also saves the effort of debugging more code, so you have very few lines of code to debug. Just print statements will help you understand where is it that it is going in the wrong direction. And needless to say, uh, the lesser the code, the lesser the maintenance. And all these really help one developer to focus more on addressing the problem than on struggling with finding the appropriate structure syntaxes for uh, addressing a data science problem. Now, program portability. Python programs run unchanged on all computer platforms. So if you have Python interpreter installed on Windows, Linux, or Mac OS, and if you write a script on any one of these, you will be seamlessly able to run those scripts on other environments, provided you have the same set of libraries already installed on all the environments. Now, Python has comes with a large collection of pre-built and portable functionality known as the standard library. Now, these libraries support an array of application level programming tasks, right from text pattern matching to network scripting. And if you say you have all these libraries at your disposal, your job really becomes easy. Just to show you some of the examples on this. So here is a default Python editor that is called idle. It comes shipped along with Python. So if you have installed Python, you will see it on your system. I'm using Python version 2.7.5. You could use any 2.7 subversion. So let's say I want to know what is the path variable on my operating system. So all I would have to do is say import operating system that has all these utilities, and I say operating system dot get environment, and I pass the name of the environment variable on which I want to find this information. That's how simple it is. And let's say you want to know what all keywords are supported in Python, or okay, let's cover that because that's already there as part of this module. Let's cover that later. So let's say you want to create a password, and you want that to be a random password of length 50, and it should be so random that even you should not be able to guess what the password is. So in order to generate such strong passwords, all you have to do is just write this one line of code that helps you generate a password. So you say random.choice, and within random.choice you use a string.ascii letters, and you say string.digits. So string is a library that has all these constants defined. If you say ASCII letters, it has a list of all the ASCII letters. If you say digits, it has a list of all digits. And now from this random choice, we run a loop from which we do not want any values, but all we want is that loop should run at least 50 times. If you say range is a function that runs like a sequence from 0 to 50. So, but don't worry about these features because you'll be learning all this as part of the upcoming modules. And this is how simple it is to generate a password, random password of length 50 in just one line of code. All you have to do is use the randomization over the set of ASCII letters and digits. Isn't it simple and cool? In addition to this, let's say you want to find out the list of files available on your current directory. So let's say uh, in order to understand what is the current directory, you could issue this command with OS, which is operating system.current working directory, and you get to know this. Now from this directory, I want to get all the files that bear extension text. So how do we do that? We say file name for file name in, and you again use operating system dot list dir, that is list all directories in my current file path. So we need to specify the file path, which is my current working directory. And then I say okay, let me run this because this will throw an error because I forgot to import, or let me save this. I'll say from fnmatch import fnmatch. So this is one of the modules that is kind of a wrapper over regular expressions, and it saves you the effort of writing the actual regular expression. So if you have the habit of finding files on your system, just say list asterisk.test and text or asterisk.python extension. So fnmatch module helps you run all that in just one single command without worrying about the regular expression. All you have to do is say if file name, or if you say if fnmatch and you specify the file name, comma, the pattern you want it to match. So you would say asterisk.text and that's it. You are done. So you are able to list all the files, and if you just run uh, the operating system .listdir on this current working directory, you will see all these files. So Windows log, remove GUI, remove pip. So you see so many files, but then only readme.txt, news.txt, and license.txt are the ones returned because we use an fn match to only list those files that have text in them. So this was just to reinforce the capability of these standard libraries in Python that really make your day-to-day job very simple. Now coming to component integration, Python also has capability to talk with other applications using a variety of integration mechanisms. So if some of you are familiar with the capabilities in Python, wherein it had uh, some libraries for getting uh, the code read by the barcode scanners or the image detectors. So, and we use libraries called com decom. Similarly, Python also has the capabilities and similar libraries to support functionalities similar to com decom. And lastly, if you learn a language which has so many cool features and it is so high in software quality, productivity, portability, and has the backup of several thousand libraries helping you do whatever you wish to on internet or on web or anything related on big data or data science. Probably there is a high degree of enjoyment you have because you have learned this language, and that's the reason you all are here, and I'm sure you have made a right choice in taking up this course. Now here is some historical background on Python. Python was invented in Netherlands by Wido van Rossum, and it is named after a famous comedy group in London called Monty Python. It is open source interpreted, so anyone can download this Python interpreter, any version, and get it started. So it does not prohibit anyone from learning it. It is considered a scripting language, but it is much more than that. As I mentioned, that nowadays organizations have come up to the level of rendering heavy websites using Python, using Jinja templating engines, combining Python with AngularJS, or developing web servers using Python. So it is much more than a scripting language. Mere scripting language like PHP and Perl, they do not have all these capabilities which are there in Python, considering the depth and breadth of this language. It is increasingly popular, and it is being used by Google for several years. It is an scalable programming language. It is object oriented and functional in nature. The job trends from Indeed.com shows that there is a remarkable increase in the number of people working on Python, and people are switching jobs, learning Python, and moving on to a newer role where they get to use Python. So Python is at the top list among the top dogs like Java, JavaScript, and PHP. And here are some of the facts to support that. If you see the graph, that is from Indeed.com. That's a popular job portal. And below are some other links. Again, uh, giving it a stamp of approval. So here are some of the popular users like YouTube, Yahoo, Dropbox, Google. They all have been using Python, and if you notice, they all are different kinds of portals. So YouTube is for video content, but it's written in Python and MySQL. Yahoo uses it for mapping lookup services that are implemented in Python. So Yahoo Maps use Python. Dropbox, being a web-based file hosting service, is implemented using Python. So both the Dropbox server and the desktop client are both written in Python. That's how simple it is that it can bring up such a cool utility available for everyone. Google, many components of Google Spider and search engine are written in Python. So that's again a note of credibility. Zope Corporation, it's developing powerful web application servers using Python. So here's a link to that. And similarly, there's Ultra C is a package management system on Linux and Fedora systems, and that is managed using Python. That is why, uh, like Java, which used to come shipped along with several operating systems earlier, now Python also comes shipped along with Ubuntu and some of the Linux systems because of the dependency of several libraries on Python. So traditionally, Python was used for embedded scripting or just for uh, writing normal scripting task, but in lately it is getting used in almost all complex streams like artificial intelligence. So machine learning is a branch of artificial intelligence. Image processing, that is deep learning. Deep learning is one of the complex problems to address in machine learning. And the data science bowl which we discussed, it was all about, it belonged to the category of this problems, image processing, deep learning in machine learning. Then you could create fancy GUIs using these libraries in Python called Kinter, GTK, Windows. Then you also have something called Python widgets, and you have GUI to Py, too many of them. So that's the beauty of learning Python. Whatever problem you want to address, and if you search for it, you definitely have one or the other library available for it. You could do database programming using Python. So it also talks back to legacy data systems. So you could pull that information from legacy system, push it to Hadoop environment using Python as a mediator between two ecosystems, and then do machine learning problems or do cool analysis on this data. It can be used for as for several system utilities, as we have seen. Operating systems similar to that, we have multi-threading libraries in Python, sub-processing libraries in Python that make tasks run much more faster. And these libraries are very easy to learn and use as compared to doing the same thing in Java or C++, wherein you have to worry more about how many threads are there in the current uh, pool, and there should not be any memory leaks errors, and it should be within the limit of threads supported on a JVM. So Python overcomes all that. Lastly, it can be used for internet scripting. I shouldn't be using the term lastly, but just on this page it says it can be used for internet scripting, but the users and the applications of Python are way beyond uh, these application areas, and we can talk at length over several pages to help you understand where all Python can be used. These are some of the current uses of Python: forecasting, analysis, ad targeting, risk management, and here are some of the facts. It says new use cases of Python are the major growth driver for increasing demand for Python skills. The use cases are emerging because of several reasons, one of which is the new packages that get added to standard libraries such as PyDoop. PyDoop is a connector in Python which helps you connect Python to Hadoop. Similarly, you have PyMongo, which helps connect Python to MongoDB. You have Pandas that helps you do data analysis. You could do data analysis at the level of a spreadsheet or a text file on your system without even storing or cleansing that data in the database. So that's the beauty of it. SciPy stands for Scientific Python, and it has so many complex features in it. Like you could do differentiation calculus, you could do integration calculus, you could calculate probability density function, you could do random variates, you could do uh, too many complex statistical tasks using SciPy. And most importantly, it's not only feature rich but also very efficient. And because it has been significantly used by several people worldwide, it has that stamp of approval that you won't land into errors using any of the standard functions here. And the best part is it has almost uh, I would say more than 100,000 algorithms implemented in it, like Bernoulli, Poisson, Gaussian. Uh, Similarly, I mean, all those belonging to these categories, Bernoulli, Bresnel, so all these are there. And we will see how to use all of these in future sessions. So a lot of uh, this information is coming your way in the upcoming modules. These are some of the popular, again, some of the popular users using Python for data analytics, and you could see the different areas of application. The last one is interesting. That's a popular national laboratory in US, and scientists in this laboratory use they work on theoretical physics division, and they use Python to control large scale physics codes on massively parallel supercomputers. And recently there was an addition of two very feature rich libraries in Python called OpenCV, that is Open Computer Vision, and called SymPy, SYMPY. SymPy and OpenCV. OpenCV gives you capabilities to do some CUDA programming. CUDA programming is the uh, one of the most popular skills that is being nowadays discussed in the market, wherein you get a graphics card installed on your system, and using the capabilities of that graphics card, you can analyze high or low quality images, extract features from those images in a very fast and efficient way using CUDA network, and you could supply or convert that analysis to a machine learning problem, wherein you can anticipate what the output or what the category of the new image will be, and you get this done in a fraction of seconds, doing this over terabytes of data. So, and the beauty of it, you could do it from a normal or a regular laptop, having almost 4 gigs of RAM. So that's how wonderful these libraries are. So OpenCV helps you do that. SymPy helps you or gives you the capability in writing mathematical formulas as it is, and there is a Python library which has the capability to convert those formulas into algorithms. So imagine a data scientist would all have to worry about learning what formula to apply, or for the people who are there from advanced mathematics background, they don't have to learn Python at all. All they have to do is write the formula, use SymPy library, and say, give me the algorithm, implement it in Python so that I can start using that algorithm which has this formula implemented. So these are one of the latest and most popular additions to Python library stack, and such additions keep coming. So there's reason to cheer for everyone that you are learning Python and you will have access to all these libraries, and I'm sure you will start using them as well in solving day-to-day problems. Now here is some statistics on the versions in Python. uh, Python version 1 was released in January 1994, and then subversion 5 and 6 of this version were released in 7 and 2000 respectively. So there was this timeline gap. It was expected in 1994, it wasn't released, but then the first version was released in 1997 end. So it's like 4, 5, 6, and 7, almost 4 years late. But then Python made up when it released Python version 2, that was expected in October 2000, and it was released in April 2001. So though there was a gap, but just a matter of 6 months. So Python version 2.7 is considered to be the most stable version, especially anything starting beyond 2.7.5 until 2.7.10 is considered most stable. And using this version gives you the benefit that most of the libraries are still supported on this version. So even though version 3 was released several years ago, but there were too many issues when version 3 was released, and due to that many libraries did not have uh, the equivalent conversion available in version 3. So in order to ensure that you have access to almost all libraries in Python, Python version 2.7 is the safest bet. Version 3 again was released in June 2009. It was again almost 6 months late. But then Python version 3.4 is considered quite a stable version, but then it's still the beta version and undergoing some tests. So let's hope we have some version of 3 standardized version available very soon, and all libraries should be supported on it. So which version to use? You could use any version. I use 2.7.5. You could use 2.7.6 or anything up to 2.7 subversion until 10. And I've already told you the reason, because version 3 is not adequate to fulfill day-to-day business needs because of its lack of support for all the Python libraries. Most of the softwares using this use this version 2.x. I wouldn't buy this 2.x. It's actually 2.7, any subversion. That's the most stable one, and that's the most widely used version in Python. So here's the funny pictorial which says that uh, you are flying and your friend asks how. You say because you have learned Python, and then your friend asks how is it that you could fly learning Python. It's not so that you will invent an object that makes you fly, but it's a pun around the capabilities that you will have after learning Python. So you would have learned object-oriented programming. So even though you are new to it and did not get a chance to learn it in Java, Python really makes it very simple for you, and you can learn the object-oriented principles here and write your own classes and objects in Python. Python is an interpreted language, so you do not require a compiler. You just have to write a script and start running it, and interpreter is intelligent enough to take care of the compilation. Python is quite dynamic, so and it's scalable, so you could just create static content like the HTML web page we generated, and then uh, with this generic dynamic content you could keep on replacing it with the actual placeholders. So this is commonly a commonly used feature in Python, especially when used with Jinja templating engine for rendering websites. Python is highly readable because it enforces indentation, unlike other languages which allow you to write dirty code or dump it anywhere in curly braces or parentheses. Python overcomes that limitation, enforcing you to write that in a legible way. Python is quite interactive. The shell that we have seen, you would have seen how easy it is to execute commands on this shell, just writing one command line, and you are there filtering files with a specific extension. You are there generating passwords in just a single line of code. And then Python is also functional, so that means it has recursion capabilities. And when we say functional, so functional paradigm supports two primary concepts called higher order functions and first class functions. So I do not want to confuse you right at this point, but it will be more logical to talk about the functional programming details when we cover functions and sorting in module 3. Now, how to get Python installed on your system? So Python is, as I mentioned, is pre-installed on several Unix systems, but including Linux and Mac OS. The pre-installed version is again 2.7. You can check the version installed on your machine by executing the below command, Python version. So if I have the command prompt open, and if I want to check what version of Python I have, though you already know what it is, but this is how we check the Python version. So you could refer detailed installation guide in LMS that will help you get Python installed on your system. There is also an Ubuntu virtual machine available for practicals, but then you will, though it has Python installed, but you will still have to install other supporting libraries on that VM. So that is to help you understand how the installation works, and so that you also have a command that installing new libraries. Now, Python interpreter has several built-in functions like help and pydoc. Let's see how to use them. So we are already on the Python shell, and if you just run this command dir, you will know dir helps you understand what is there in this current environment which you are running. So it has uh, some of the I would say namespace variables. So built-ins is a namespace variable, similarly doc. So just merely by looking at these variables, these are not so common to create by anyone, having leading underscores and trailing underscores. So these are all the built-in variables. It will also show those variables which have been created by us and the libraries imported by us, like fnmatch, operating system, random, string. So when we run an idle shell, it's actually our current namespace, and when you run dir command, that tells you what all exists in this namespace. So now let's say, how do we access help in Python? So that simple it is. You could say help, type the command, say for, and that gives you that for loop. For is a keyword in Python that is used for creating for loops. So if you just say help for, you learn what is there in for, how to use it. If you just say help, leave it, that actually takes you to the help interpreter within Python interpreter. And you could just say for here, that gives you information on for. You could say raw string here, that gives you information on raw string. Or if you just say, uh, I would say while loops, or if you say lambda, so you have information on all these functions. Lambdas are commonly used functions in functional paradigm, and these are one of my personal favorites in Python, considering the capabilities and the simplicity in writing code using lambda functions. Now if you have to come out of help in help command line, all you have to do is just type quit. You're out of it. Now let's say you also want to access help using one of the modules in Python called pydoc. So this is how you access help. You say python -m, which stands as command line argument for using one of the modules in Python. So if you say pydoc and you say you want help on topic lambda. So if you do this, you get to see the same help that we saw here, lambda form. Related help topics are functions, what are the name arguments, expressions, what is a yield object in Python. So all that information is same. It's just that the way of accessing it is different. On shell we do it using help. On command line we do it using pydoc. On command line you can also run a Python interpreter, just say Python, and this is similar to what we are seeing in idle. So if you say help here, that takes you inside help. Now just say lambda for while and then quit. Again, to exit from Python interpreter, you have to use exit followed by parenthesis. It's kind of a function that you have to call. So that's how simple help is. Uh, when you run Python interpreter, you also see that this environment has something called type copyright credits or license for more information. So if you say copyright, that shows you what are the copyrights on this Python version that you are running. If you say license, sorry, you have to use it as a function. Sorry for the typo again. So that tells you about the Python license that is being used. It is offered by Python Labs Digital Creations, now called Zope Corporation. You say quit, and now if you say what are the credits, the contributors to Python. So it says thanks to CWI, CNRI, Open, Zope Corporation, and several other thousands supporting Python development. So you could see more if you visit this link, python.org. All right. Now moving on. So we have already seen how to use pydoc. Pydoc is a documentation module for Python that is installed with any Python distribution. It can also help you generate HTML pages with documentation specifics. So I would leave it on you to explore, and this is one of the most simple modules to use in Python. Now IDE, that stands for Integrated Development Environment, and when we say integrated development environment, it's the kind of an environment which helps you write Python script, set up projects, export projects as a shareable library so that you could also be a contributor to the list of packages available in Python. So such environments help you write or deliver code in a specified format. And the beauty of using such editors is they also guide you if you are wrong on some syntax. So there is a red line on your code whenever you write something wrong, so that before executing this script, you know well in advance where is it that you have made a mistake. So for the purpose of this course, we will be using PyCharm editor. That is one of the uh, most simple editors to use. And if you prefer some other environment, we are open to it. So there are other IDEs available on Python like Aptana, which is a kind of a flavor of Eclipse. Similarly, there is a version, or I would say a library available in Eclipse that helps you run Python code as well. So you could choose your IDE, but then if you want to stick to what we use in this course, you are welcome to use PyCharm. And here is a link for downloading PyCharm. Download the free edition. You're not required to pay because we do not require these uh, complex features to be leveraged from this tool like Django, Flask, App Engine, Pyramid. So get to the download community. To start Python, we have already seen just on the command line, you say Python, or if you say Python hyphen double hyphen version, that tells you the version of Python. So whenever you enter a Python shell, you will see these symbols that is 3 times greater than. This signals the start of the interpreter. And if you also want to restart your interpreter, there is something called a restart shell, control F6. If you do that, so all the variables in your namespace are lost and you will have to recreate those variables. So be careful when you do it on interpreter. However, I'm sure going forward, most of you will just try some piece of code on interpreter, which is temporary because you will not be able to save the scripts that you or the code that you write on Python shell. So in order to save such a scripts, you'll fall back to IDE, PyCharm, create a scripts and then save them so that you have them available for reuse in future. Now, coming to some of the syntactical details in Python, like how to create comments, bulk comments, and literal constants. Let's address some of these. So in order to create a string, so this is a Python script, example script, and if you have to create a string, okay, let me take you to the top. Let's create a string. So let's say you want to specify uh, the I would say creator. Who's the creator of this script? You say Edureka. So when you say Edureka in double quotes, that becomes a string. So Python is not a typed language. Depending on what you assign to a variable, the variable becomes of that specific type. Similarly, you could create a strings using single quotes. So Python gives you flexibility in either using double quotes or single quotes. In addition to creating strings like this, if you have to create a single line comment, you could say this is a single line comment. And if you have to create multi-line comments, you could choose something like triple quotes. So you could use triple single quotes or triple double quotes. So you say multi-line comment 1. Similarly, you could write multiple lines inside this 2, 3, 4. So this becomes your multi-line comment in Python. But there is one word of caution in using this comment format. Don't try to mix single quotes with double quotes. That is something which will not be deciphered by the interpreter or any of the Python scripts. So if you say starting is single quotes, single triple quotes, and then you say closes triple double quotes, you could see the code below is all green, which indicates that everything in this script below is still considered a quote because we did not close the way we started. So in order to do that, this is how we do it, and you could see the color of the code below this, fun, print, it all changed. So this is how you create multi-line comments in Python, and you already know how to create a strings. Now there is a method called type that can help you understand what is the type of an object in Python. So as I mentioned, Python is not a typed language, but if you create a string like this and you want to know the type, so you could say type function and then pass the variable So that tells you it's of type string. Similarly, if you say a is equal to 10 and you say what is the type of a, you get to know that it's an integer. Now Python supports different types of numbers, uh, namely integers, long integers, and floating point numbers. So some of these have an analogous point in C as well, wherein such numbers were implemented in C as a uh, different data type. So if you are familiar with C programming language, whatever is considered as long in C is the same as integer in Python. So, and here is some note around it. If you divide an integer by another integer, that will return only the integer part of the quotient. Uh, and if you divide it by any floating point number, that will give you the fractional part as well. Now, long integers in Python can be created by just hitting too many numbers or assigning it to a variable, and then at the end of such a long number, you have to type either capital L or a small l to indicate to the interpreter that this is a long integer in Python. Now, floating point numbers, you do not have to tell to Python interpreter that you are creating a floating point number. So the moment you create the decimal part, or you just say a number dot and leave the decimal, that indicates it has to be treated as a floating point number. And it could be fairly long using these notations as well, like the pi notation or exponent notation, and these are implemented as C doubles. So these are their equivalent of floating point numbers in C doubles. Division works normally for floating point numbers, so you get to see the fractional part when you divide either an integer by floating, or floating by integer, or floating by floating. So if any of the um, divisor or the number is in floating, you get to see the fractional result generated. Now operations involving both floats and integers will only yield floats. And then we have some other different types of numbers in Python called octal, hex, and complex numbers. So octal numbers, for those of you familiar with some of the binary programming, you will know that binary numbers have base 2. Similarly, numbers that have base 8 are considered octal numbers. And the way you create octal numbers in Python is you just have to prefix 0 to the number. So in case you accidentally write a number without single quotes with 0 as the leading number, probably that will reflect some other value when you try to print it, because you would have created an octal number. And you will face an error if any of the digits or letters in that octal number is beyond 7. So octal numbers support all letters between 0 and 7. Similarly, hex constants, they again begin with 0 followed by small x or capital X, and then followed by numbers 0 to 9 or letters A to F. So 0 to 9, you can very well understand it represents the first to 10 number, and then A to F will represent 11, 12, 13, 14, 15. So again, the rule of thumb in hex is you cannot write anything other than A to F or 0 to 9, because anything other than that will cause an error if it has a 0 and x as the leading uh, digits specified. Now, complex numbers, these are commonly used in some complex mathematical operations. So this is the syntax to write them. It must either end in a small j or a capital J, and the imaginary part first will return the complex number in the order, read the number and the imaginary part. So let's see some of these. So if you say we already have created a, let's say we create b is equal to 2, and if you say a divided by b, so you get 5, and let's say c is equal to 3, and you say a divided by c, so you get 3, because 10 when divided by 3 will give you 3, it will not show you the fraction part. Now let's say c is equal to 3 point, right? And then we say a divided by c, so you get the fractional part as well. So creating a number like this 3 point will create a floating point number, and when the division operation has any one of the numbers as floating point, you get the fractional result back. Now, what are the Python identifiers and rules for variable names in Python? So Python identifier is used to either create a variable, uh, a function, a class, a module, or any other object in Python. So uh, but in order to create any of these objects in Python and assign them a variable, assign them a name or an identifier, you will have to follow some rules or guidelines. So these rules are: an identifier can start with a letter A to Z capital or A to Z small, or an underscore followed by zero or more letters. So when you say followed by zero, you could also create an identifier saying underscore is equal to something. So even underscore can be treated as an identifier in Python. Uh, you could write letters and digits followed by an underscore or even without an underscore. So Python being a case sensitive programming language, so if you create um, Apple as capital and then again create Apple as a small, so these two are considered different identifiers. So don't expect the small apple to show the value of the bigger apple. Python does not allow special characters, so if your identifier has any of these in them, these will be considered invalid identifiers and you will see a syntax error. So if you have at, dollar or percent within any of the identifier names, you will see an error around them. So variables, how do we create them? We just type a name like we did creator is equal to Edureka. So creator was a variable and Edureka was the constant assigned to it. So variables are just created by assigning them a value. It does not require any declaration like Java wherein you have to say string creator and then say creator is equal to some value. So no declarations or data types required in Python. And there are some naming conventions that we need to follow for Python, like class names should all begin with an uppercase letter and all identifiers with a lowercase. Now, these are just the naming conventions. Python interpreter does not prevent you from using a different case altogether, but then uh, to be on the right side and to ensure that your code is comprehensible to other Python developers and you follow the same guidelines for as the ones followed by your peers. So to be consistent, stick to these guidelines. Wherever you create a class name, the first letter of that class name should be an uppercase and all other identifiers with a lowercase. If you create an identifier in a class with a single leading underscore, that indicates that particular method or a variable inside a class is uh, private. I would say it's more protected than private, because to create a strongly private identifier, you will require two leading underscores as mentioned on the next line. And if the identifier has two trailing underscores as well, so the identifier is accorded a special definition by the Python interpreter. So remember when we ran the dir function here, we could see some special methods like built-ins, creator, and if you say if you pass built-ins to dir, so that will tell you what all built-ins are brought in by the Python interpreter. You could see string, power, print. So all these common functions which you'll be using in your day-to-day work using Python, you will see all those come from dir function. Similarly, it has a library for keywords that lets you know what all keywords are there in Python. So if you say import keyword and say keyword dot kw list, that is keyword list, that tells you what are the keywords in Python. So not a long list here. And if you say you want to know whether the word which you are using is actually a keyword or not, so if you say keyword dot is keyword and then you say bool, sorry, I did not type it correctly, so it should be keywords. Again, it shouldn't be plural, it should be keyword as mentioned in the import. So you say keyword dot is keyword and then you type bool. It tells you that boolean is not a keyword. So you could use boolean as the keyword, but if you say keyword dot is keyword and then say def, so def cannot be used as a keyword. Probably you could write it in single quotes. So it says it's a keyword. I'm sorry, the bool should have also been written because it's not able to understand when we type bool in just like that. So if you say bool, it says again false. Bool is not a keyword. And then if you say, you could see yield as one of the keywords here. And if you say keyword dot is keyword, so it says true. So whenever you are not sure what keyword you are typing or using, you can fall back to this library in Python that helps you understand whether that particular word is a keyword or not. So we have covered the identify naming conventions for Python, especially related to class, that they should begin with an uppercase letter. They should be, they can be identified with a single leading underscore, with two leading underscores, with trailing underscores, all getting a different meaning as respectively as protected, private, and special. So keeping these identifier rules in mind, I have a question for you. So that question comes from our regular friend in all the courses called Annie. She's quite inquisitive and helps you understand some of the concepts better by posing challenging questions. So here is one question from her. She says, which one of the below identifiers is incorrect, whether it is underscore var, double underscore var, dollar var, or var? I leave it up to you to think about it and answer. Rahul, Anand, Jeff, Elvis, Tom, any guess? Cool, all of you are spot on. Right, so $var is incorrect because if we recollect, the last line of the identifier says, identifier rule name says that at, dollar, and percentage cannot be within identifiers, and we have dollar in the third choice. So moving on, let's see what all operations are supported on numbers. The basic algebraic operations. So there are four arithmetic operations commonly used in all the programming languages, or supported in all of them, namely addition, subtraction, multiplication, and division. So needless to say, Python also has all of these. In addition to this, it has modulo, which gives you the remainder of the from the division result, exponentiation, which raises value a by to the power b, and there are other elementary functions. I wouldn't say elementary because even though they are elementary, but the packages like numpy and scipy, they are not part of the standard package, standard Python, but can be installed externally as the libraries from Python package index. And when you have them, they have numerous capabilities. So I'm sure you would recollect I said you could do integration, differentiation, uh, advanced statistics, random variates, probability density. So when you say all those are part of these packages, so you have access to those arithmetic operations available in SciPy. So I usually consider them advanced mathematical operations. And in addition to this, the SciPy also supports the elementary functions like addition, subtraction, sum, counting, grouping. So mean, standard deviation. So all these functions are there in SciPy and NumPy. Now, apart from algebraic operations, there are some comparison operators available in Python. These are the ones. I won't read them because most of you will be familiar with these. But then in order to do identity test, which is around finding if an object is equal to another object or a value is equal to another value, we use double equal as the equality operator, or exclamation equal, which stands for not equal, for confirming that two objects or values are not equal. So you could use these comparison operators and identity tests. I'm sure you will not confuse identity operators with the assignment operator, which is used for assigning values to the variables, where you use only single equal to. And he again has an interesting question for you all. So she says, when the value of variable a is 5 and b is 2, then what do you think will be the value of below expression? So this the left side is simple to comprehend. The right side is a little complex, and I will require you all to spend a minute to let me know what do you think will be the answer to this problem. Okay, cool. Anand, Rahul, Jeff, Tom, Elvis, all of you are correct again. So we say the answer is false because both expressions have equal value called 30, and because we say if expression on the left is less than expression on the right, so the comparison of these two expressions with less than symbol will always give you false because the two are equal. Continuing on the operations on numbers, so we saw the algebraic operations and the comparison operators. Now we see what are the bitwise operators. So bitwise operators are helpful working on binary numbers, and in case you're not aware of binary numbers, feel free to stop me. Otherwise, I assume that most of you will be aware. So in binary numbers, 111 represents 7, 101 represents 5, and the commonly used operators in binary set are bitwise or, bitwise and, using pipe, ampersand, or bitwise exclusive or A XOR B. So when you apply these operations over these two numbers 7 and 5 represented in binary, when you do an or means when both the bits are 1 or one of the bits is 1, you get the outcome as 1. So that's why on all three you have the first number having all bits as 1, so you get that as the output. In AND, the rule of thumb is if both the bits are 1, then only you get 1, otherwise it's 0. So if either one of them is 0 or both of them is 0, the outcome is 0. So 1 1 gives 1, 1 0 gives 0, 1 1 gives 1. So that gives you the final result as 5. Now XOR operator, exclusive OR, works little differently. So XOR follows the rule that if both the bits are same, you get the uh, final result bit as 0. So only if the bits are different, it does not matter whether it is 1 0 or 0 1. If they are different, you get the result as 1. So 1 1 gives 0, 1 0 gives 1, 1 1 again gives 0. When you translate this binary number to decimal, you get 2 as the result. Now there are some bit shift operations also available using double less than and double greater than symbol like this, but these are not so commonly used. With my experience, I could say that for those of you working in financial services and have to deal with some encryption mechanism to be imposed in the data exchange messages or the files, usually in such places bit shifting is used to obfuscate some of the starting letters and the end letters to make sure the data that you share is not comprehensible by anyone in the network, and it's only the end user who has the key to again decrypt that data back using the reverse shift operations to understand what that actually contains. So I have used these operations uh, communicating between different when communicating host banking systems with all the external ATM machines to ensure that the messages are safely encrypted. So I'm not sure if all of you have this experience or you might have a better case or usage for these features. Now we move on, and then we have another interesting question from Annie. So wants to know what is the output of 2 or 4, 2 and 4 and 2's or 4. And let me help you understand what is 2 represented in binary. So 2 is represented as 0 1 0. You already saw that as part of the XOR operation. Don't go by the operation that got performed on this. And if you say 4, 4 is represented as 100. So considering 0 1 0 and 100, you now have to perform the OR and the XOR operation. I'm sure this would have made it simple for you. Okay, so allowing you a minute of time. Right. So most of you are correct, but for those who did not get the expected answer, let me walk you over that. So when you say 0, 1, 0 and 100, and when you do an OR operation, so OR is if any one of the bits is 1, you get 1. So 0, 0 will give you 0, 1, 0 will give you 1, 1, 0, 1 will give you 1. And when you translate 1, 1, 0 back to decimal, you will get the value as 6. So for sure the first answer is 6, but you have again three choices, so there is still time to rule out what is it that is not an appropriate choice. Then we say AND operation. AND means if one of the bits is 0, the outcome is 0. So in this case, I think all three will turn out to be 0. 0, 0 will give 0, 1, 0 will give 0, 0, 1 will again give 0. So 0 has no value, so it's like 0. So we now have boiled down to two choices, A and D. Now it's a question of identifying the value for the fourth, which is XOR. With XOR, we know the rule of thumb is if the bits are different, we get the value as 1. So for the first bit 0, 1, we get 1. For the next bit 1, 0, we get 1. Last bit 0, 0, we get 0. And you know 1, 1, 0 is 6 because that was the result from 2 or 4 as well. So the answer to this problem is 606, that is choice A. And in addition to the operations we have seen and the different binary numbers and operations supported on those numbers, we have some rules to be followed in evaluating expressions in Python. So most of the programming languages follow a rule called BODMAS, which is body of division, multiplication, addition, and subtraction. But then Python follows a different rule called PEMDAS when it comes to evaluating expressions. So PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. So when you say PEMDAS, parentheses get highest precedence followed by exponents and then so on till subtraction on the order of operation. So with this rule to be followed, what do you think will be the uh, expression evaluation on the right side? So if you take a look, though you have the answer available, but try to give it an attempt uh, and then see what is the answer. So evaluating the first expression, it says subtraction, it has multiplication, and it has modulo. So keeping these rules in mind, multiplication comes first because we do not have parentheses and exponents. So it is 24 into 3, that is 72, followed by division. So modulo is I would say a subtask of division, wherein only after division you get to know what is the remainder. So when you say 72 modulo 5, that should give you the remainder as 2, and then when you subtract 2 from 100, you get the final result as 98. Now if to the same expression you just do little modification, as in adding parentheses on 3 modulo 5, so now that you have parentheses, so this should be evaluated first because that's the highest precedence. So 3 modulo 5 will give you 3 because 3 when divided by 5 gets you remainder as 3, followed by multiplication, that's next. So we say 24 into 3, that gives you 72, and then you do subtraction and the final result is 28. So you would notice that parentheses can entirely change your expression. Based on the PEMDAS rules, what do you think will be the output of 100 into 20 to the power 2 divided by 4? I think this won't take more than 20 seconds for you all to give it a try. Okay, Nice, Rahul. Mm-hmm. Yeah, makes sense. Okay, so now let's unpack some of the details here. So keeping in mind the PEMDAS rule, we see there is an exponentiation operation here. So 20 raised to the power 2 shall give you 400. 400 followed by, and then after exponentiation we should perform division because PEMDAS is no, followed by that we should perform multiplication. So PEMDAS is multiplication and then division. So 100 into 400, that is 40,000, divided by 4 should give you 10,000 as the result. So it says exponent will be calculated, then multiplication, and finally division. And here is the explanation on the evaluation of this expression. Now moving on to strings in Python. Python does not support a character type. So in Java, you could create an object called char, which is capable of holding only a single letter. And similarly, you have a string which is capable of holding a sequence of characters called a string. But Python does not have any such classification. So whatever you create in single quotes, whether it has a single letter, multiple letters, or it's just a single quotes without anything inside it, it's actually considered a string. So there is no character in it. And this is the most important aspect of the strings in Python. They are immutable. Sorry. So when we say strings are immutable, it means once created, it is difficult to change them. I mean, there are ways to do that, but then you will have to either change the variable or reset the variable to something new, but you cannot alter an existing string. So if you say s is equal to Edureka, and if you say s dot replace, you specify what letter to be replaced. Let's say you call small a to be replaced with capital A, right? So when you say s dot replace, it will not have the effect of changing the actual s or the string that you have created. If you still hit s, you will see it still has a small a in the Edureka. It means that did not get changed. And if you try to delete any of the elements in the list, so using delete, del is the keyword. If you say delete and then you specify lists, I mean the strings are treated quite similar to lists in Python. It means they are iterable. So okay, let me show you how to access a specific elements in a string. So you say s of 0, that gives you the first letter. You say s of 3, that gives you the fourth letter, because it starts from index 0 and goes to the length of the string minus 1. So 3 will actually give you the fourth element. And now let's say you want um, a series of letters. So you say start from the second position and go until the fifth position, but excluding fifth. So one is inclusive and fourth is exclusive, going by the index position. So you get dur from Edureka. Similarly, if you have to delete few letters from a string or a specific set of letters from a string, you have to specify delete. And let's say we want to delete the first E call Edureka, and that's where you get this message. A string object does not support item deletion. It means you cannot alter the state of existing object because the strings are immutable. So some of the workarounds around this is you say you create a string like s is equal to list and you say Edureka. So it still remains the string, but when you print it, it's printed in different letters. So you'll have to print it something like double quotes dot join all the elements of the list, and then you pass the list. So you get Edureka back. And now if you want to delete any elements in this list, you could say delete s of 0, and again if you print s, you get Dureeka. So this is how you could uh, eliminate some of the or perform some of these operations on a strings which are immutable. So not direct operations, an indirect way of getting things done. Or if you are comfortable changing it to a different variable, you could say uh, again create s as Edureka. And if you want to get rid of s, a capital E, you would say s2 is equal to S, and then you specify a colon. Start from that position before which you want to get rid of the letters. So you say start from 1 but go until the end if you don't specify the end position. And now if you print S2, so you get Dureka. So this is how you could perform string operations in Python. The strings are ordered blocks of text. They are enclosed in single or double quotation. We already know how to create a strings. Double quotation marks will allow the user to extend strings over multiple lines without backslashes. So this is one more capability that you can leverage when you use double quotes, uh, which usually signal the continuation of an expression. You can concatenate strings. So if you use the plus operator, you say s plus s2. So that has the effect of joining the two strings together. And if you say s into 3, that has the effect of joining s to itself 3 times. So even though these operations are mathematical operations, but when applied on strings they work differently given the change in context in which they have to deal with these values. Now, indexing and slicing operation, you have already seen how to access elements from a list, specifying the position of those elements. So it starts from 0 and goes to the length of the string -1. And similarly, you could slice a piece of text from a string, specifying the start and the end position, or you could leave the start position and specify the end position, or specify the start position and leave the end position, and vice versa. Now, you could also check if a string has a certain letter in it. So if you want to check if A is there in S, this is this simple. You just have to say letter followed by N. You could also have a string check within a string. You could say dur in S, that tells you true. And if you say edu in S, any guess what do you think will be the output? True, true. Okay, let's see. This is false because if you notice the E in my string is small, but then the string S has ES capital. It has a small e, but then the sequence is not there. It is EKA, but EDU has ES capital. So in order to do case insensitive match, what you could do is you could say EDU and S dot lower. That means because I have this string in lowercase, let's check, make the actual string also all lower and then perform a check so you get to see true value. In addition to the in operator, you could also check the not in operator. So if you say the same thing edu not in s, you will get true because a small edu is not there in s. This is quite simple. Now in order to do formatting operations, you could create a string in double quotes or single quotes and say hello, I am learning, and then say %s, which will be the name of the course, right? And now you want to substitute this s with uh, a specific course string. So you say delimit this string by a percentage and then specify the string that should be substituted. I am learning Python. And when you do this, it says I'm learning Python, where a string gets substituted by the respective string. So the sequence of the format operators should follow the sequence of the values. They should tie out to the values. So if you say I'm learning Python, I'm learning Python for the first time or for the second time, right? And I do not specify first and second, and I just run this. So it says not enough arguments for format a string because the string expects two inputs, but only one is given. So let's substitute this and say learning Python for first time, not enough arguments. Okay. So if you do this, so it tells you, hello, I'm learning Python for the first time, though you have to enclose it in parentheses to make sure the values are considered as a sequence and substituted for the respected placeholder in the string. So this is how you could format a strings. The other way of formatting strings is, which is more elegant and does not require you to worry about what data type you're passing. So you say, hello, I'm learning. In curly braces, you say what is the first value to be replaced, that is 0, and then you say 1. So these are just the placeholders. I'm learning Python followed by 1, though. So I don't understand what is 0 and 1 in this. All it says is I am learning 0 followed by 1, though 0 is my first time. It means whatever you pass as the first argument in the formatting, that will be substituted for 0 placeholders followed by the second argument with the first placeholder. So you have to use format function for formatting. uh, so you could use percentage, but then percentage requires you to specify the type of input you will provide, whether it will be %s for a string, %d for integer, but then format saves you that effort. So you could say format, and then in parentheses you type in the value separated by comma, Python, Hadoop, and if you run this, it says, hello, I'm learning Python followed by Hadoop, though Python is my first time. So this is how you could do string substitution in Python using the formatting functions. Now, like the lower function we have seen, you could run the capitalize function that has the effect of making only the first letter of the string in capital, leaving the others in lower or uh, in capital. Now, count function can be used for counting the occurrence of a string within another string. So you could also specify what is the beginning position followed by what is the end position, that could be that when left blank runs up to the end of the string. So here is an example. If you say s.count and s has Edureka stored to it, re0 length of s, so that tells you what is the position or the index of re string in Edureka. So now it tells you the number of times re string appears. I'm sorry, I was reading through index as well. So encode function, that is the next in line, that helps you encode a string. So it is quite simple and quite useful as well when you have the text to be encoded in a specified language or in a specified format. So you specify the encoding called base64 in this case, and whether you want the encoding to be strict, which means if there are any errors, it should error out and it should not consume the input if it is not able to convert that input to this encoding base 64. Similarly, for decoding, you specify the encoding to be used for decrypting the code, followed by the flag whether errors should be raised for strict matching or not. So these are some of the commonly used methods in the string library in Python. And the last one is the index, which tells you the position of the string you are searching for. So if you say s.index, this is quite similar to the count, and that's why I mentioned about index when we talked about count. So when you say s.index, specify the string to be searched in the original string, and you can specify the start and the end position. that tells you index of the position of the string within the existing string. Okay, moving forward. Now, this is the most important piece in Python, indentation. We have to ensure that all your scripts in Python are well indented, because if the scripts are not well indented, you get to see something called indent error and your scripts won't run. So that is the first check performed by Python interpreter, ensuring that your code is neatly arranged and you follow some guidelines. So these are the guidelines. It says there are no braces to indicate blocks of code for class and functions. So you have colon to indicate that, but then the colon specifies that all code below it should have at least one tab preceding it to ensure that this is kind of the next level of code within a looping structure or within a class or within a function. Now, blocks of code are denoted by line indentation, which is rigidly enforced. The number of spaces in indentation are variable, but the block, all the statements within the block must be indented by the same amount. So you could choose the number of spaces, but then this can cause complication when you try to run code over different editors. So editor, if you follow the editor specific spacing for 4 letters, or 4 spaces or 3 spaces, then probably something that works on PyCharm might not work on Aptana. So avoid doing that. It is safe to be consistent with the format specified for Python scripts by the Python community, that is 4 spaces. So stick to that. Standard is to use 4 white spaces as per official recommendation, and some editors automatically take care of indentation, and PyCharm is one of them. Now, how do you run a Python script? So Python scripts are written in text files and they bear the extension .py as a suffix. The scripts can be read by the interpreter in several ways, like Python script py. This will execute the script and return to the terminal afterwards. So let's see if we can run a script. So we have module 1, examples, HTML email, HTML web page, and Python comments. So let's say we delete this project page and let's run the HTML web page example from the command line. So let me move inside module 1. That's where I have that saved, and now I say Python and then type HTML web, and if I tab out, it takes me to that file, and it's not Python, it's Python. Sorry for the typo error. Now if we run this and go back to the desktop, we can see the page getting generated. So all we need to do is either browse to the directory where you have the file saved, or say Python followed by the qualified path of the file. So you could also come out and say Python module 1 slash HTML web page and then run this. So it's up to you, where is it you are and where is it you want to run a specific file in Python. Now that brings us to the close of today's session, and we learned about the benefits of learning Python, the users of Python, and how beneficial and critical uh, it is to learn Python for all developers. It is becoming an increasingly popular language. And then we also learned a few of the syntaxes in Python, which helps us know how to create variables, identifiers, what are the best practices to be followed, the operations on numbers, strings, how to create strings and comments. So keeping all that in mind, you have some assignments to knock off, and I'm sure you will have fun playing around with these assignments. And as I mentioned, if you face any issues in completing any of these assignments, feel free to reach out either to me or to Edureka support. Wish you happy learning. Talk to you all tomorrow at the same time. Have a good day.